Hello, good morning or good afternoon. Let me know if you can hear me.
Good afternoon, sir. Yes, sir, we can hear you.
Okay. And you can see the screen as well.
Yes, sir.
Yes, sir.
Thank you. Okay, so let's start. I'll be taking this course on big data analytics, which is kind of a compulsory course. Today, I'll just talk about generics, what we need to do, what does the course consist of, what is involved, and other assessment and other related stuff. Firstly, the resources or the material or the reading or books. As before, I won't give you any reading notes. You probably know that better. The slides are for you the referral, but they are not reading material. You need to depend upon books, go through it, and read from there. There are two textbooks. One is by first book is Douglas Eadline, and almost both the books completely make your syllabus. First book by Douglas Eadline constitutes first two modules related to Hadoop. Second book, Data Analytics by Anil Maheshwari, constitute the last three modules, module 3, 4, and 5. And part of that you might have studied as part of ML, but give you overview from data analytics perspective, what are the ML techniques you can use to get some business intelligence out of those. Dr. Anil Maheshwari is a good friend of mine. We worked together in US. So he's kind enough to give me all his slides. For the course, I will probably using those and modifying it to some extent as we deem suitable for the lecture. I would also probably request him down the line towards maybe sometime next month to give one or two overall lectures about this subject so that you get an idea. He's in the US, he's not here, the US Iowa State. So we work out the timing and probably do that and look at how does that work. Other than the textbooks, you can probably look at the Apache Hadoop website. That gives you the main information. And of course, you have Google to always depend upon, explore, search, find your answers. Once you find answers, you probably have to filter it out yourself and then see. And then Coursera and other courses you can try to. Both the textbooks do not give you deep knowledge. They give you a very, very high level, conceptual, how things work, that kind of novel details. So basically they talk of little about everything or not. So is what they say is when you do your UG, you probably know a little about everything, and when you do PhD, you know a lot more about little things. So that's the trade-off that goes on. The topics are summarized, they're given you brief overview, how does it work, give you conceptual understanding what it means, and if you're interested, you have to probably explore yourself. In the case of Hadoop and others, examples given are kind of a hello world. You know what hello world means. Write a simple program, let's say print of hello world in Python, print hello world. When you run one line command, hello world appears on the output console and they were. So hello world basically means give you very, very simplistic overview of how things work, gives you some comfort level. So the examples in Hadoop probably belong to this category. And what I suggest, recommend you is look at those hello world examples, build upon it, write your own stuff, run them, and that will give you a more deeper knowledge how things really would work. So best way to do that is take a simple program. First, make sure the simple program given as it is works. And once that works, then can you make incremental changes? And once you make incremental changes, then you know the program basically works. And keep doing it till you come to a level where you know you got a reasonable good understanding of how the entire topic or subject would basically work. And that approach I would strongly recommend you to follow it up. To work upon it, you probably need Hadoop installation. Because most of the courses, if you look at first two modules, they're all Hadoop commands. And mugging up is not going to get you anything. But to understand, you have to use those commands, run those commands, and see how the command works, what the output is. That basically means you should have access to Hadoop installation. So you need to install Hadoop on your lab setup, and we'll come to that in a short while. The process to go about it. I'll be recommending you to install Hadoop on the Linux machine, and that means you should be comfortable with Linux commands. So in case you have given them a go by or forgotten about it, it's good time now this week to review all the Linux commands, command line tools, how to create users, how to assign groups, change ownership, changing permissions, file access commands, and so on, so forth, where the logs goes, and that kind of stuff. So this week is time to review so that you become comfortable with those commands. In terms of updating your skill and getting to know better, the author of the first book, Douglas Edline, maintains his own website at clustermonkey.net, and I've given you to quick start guide. I recommend you to visit and you can ask questions. And what I noticed is whenever I ask some questions, I did ask some questions, and some issue with installations, and he is able to respond within 24 hours. If you do that, you'll probably be better off. And then the other details, installing commands, doing things. Second book is about machine learning, and this reference comes from that book only. To conceptualize the concept, look at how a given data mining and machine learning model works. You can use Weka as a tool. It has built-in models. Or those who are comfortable with Python, Python SciPy, or Python sklearn, you can use that to learn yourself either, and that should be fine too. So Weka gives you ready-made package. You just input the data, select a model, things would work. I haven't used Weka, but I did use sklearn sometime. So depending on your choice, you can do either. As I said, to appreciate the way Hadoop system works, you should have access to Hadoop installation. So ideally, Hadoop installation should work in a cluster. And I asked two of your batchmates, classmates, Indra Sena and Chenna Keswa, they did a Hadoop setup installation in the lab on 4 machine. Unfortunately, one of the machine has gone down, whatever due to distress or anything, and that's what the Hadoop is designed for. The systems could go down, but you should still be able to work. You don't have access to cluster multiple machines, so you may not see a real distribution of a workload, but to familiarize with syntax and the way working conceptually, you can install Hadoop on your laptop. Now, this can be done in two ways. One is you directly import a HDP virtual machine. HDP is Halton Data Network. The only challenge is the VM which HDP would give you expect you to have 10 GB of RAM allocated. Now, most of our laptops you got, I don't think you have more than 4 or 8 GB RAM. So creating a VM which would use 10 GB VRAM, it probably won't work, machine simply has. So it will not even work out. So better recommendation way would be install a VM, let's say virtual box. And once you install a virtual box or any other machine, install Linux. And on Linux, run the commands to set up the Hadoop. So both Indrasena and Chinna Keswa has consolidated the set of commands which you can do to set up Hadoop. You work on this link, things should open up, and you can probably see. So, can you guys see my browser window?
Yes, sir.
Yes, sir.
You basically download Hadoop. Current version Hadoop is 3.x, but all the book details things they refer to 2.5. So I would recommend you to download 2.10, the last one, to receive and install it, and then untar that file and follow the setup command. And in case your restructure thing doesn't work, you can always reach Chinna Keshav or Indrasena. They can help you out installing it, setting it up. Whole Hadoop setup is based on using Java. So make sure that your Java is working, and if Java is not running and enabled, they also give instructions of how to set up Java, which I don't want to go through. Now, Hadoop requires certain environmental variable settings for Hadoop and Java. So basically recommends you create two profile files called java.sh and hadoop.sh. And these are to be created in a directory etc profile.d. And that is where I said you should be comfortable with Linux environment, Linux working. So any .sh file you keep in etc profile.d, whenever somebody logs in, the commands will get executed and the variable will be set up. So in the two files, java.sh, you basically define the Java home. In the file hadoop.sh, you define the Hadoop home path. And all that will expect to work with that. Once you do that, anytime you log in, whichever user, this environment would set up for you. Then you have to create users and groups. So Hadoop commands require three set of users called SDFS, yarn, and MapReduce. And they also belong to a group called Hadoop. And they're given the commands how to create a group and add the group to different users. Create the three users, user add, like group. So create the three users and add the group users to the group Hadoop. It should be fine. And then you create basically data and log directory. That's what MapReduce. Whenever you upload a data or a file, they have to go somewhere. So there's a notion of a name node, secondary name node, data node, and so on. We'll talk about that in our next subsequent lecture. So define those configurations, create those directories where data would be stored. And then to make sure things run, basically configure 4 XML files. One is called core site, that is core file, that basically indicates with the default code running. And then you look at SDFS configuration, you can see if you are doing in a single machine, you set the value to 1. But if you are doing in a cluster, you like to see a replication value to 3. So the application value should always be an odd number, so that if a number of machines fail, you can still get access from a majority and you could be able to decide. Then you define basically what the name node directory is, you look at the checkpointing, synchronization, backup, data node where data would be kept. We'll talk about that in a subsequent lecture. But create those places, run it similarly for MapReduce, create a code MapReduce site.xml, define some configurations that will be using Yarn as a resource network manager for scheduling MapReduce job and so on, so forth. Having done that, you probably would know, so in a single machine setup in your PC on a virtual box, or if you already have a Linux, you can don't have to install VirtualBox. You can run these commands and set up within that. So at least what they'll give you is, even though you're not aware of a cluster, these commands will work the same way. And if you work these commands in a cluster, that also would work because as a user, all that SDFS gives you, you're transparent to what the cluster is. You get a single system image, single access, you work on it. Doesn't matter whether command is directed to 3 machines, 10 machines, 2 machines. So you are concerned, you use single command and that works. So the access and familiarization with the Hadoop commands would work much better with your own virtual machine or the Linux machine where you install Hadoop. And I would recommend you to do that within this week. First is command line setup, cluster setup. Those who want to see in the lab, they can come to the CCR in the center. The currently 3 machines are running, 1 is down. We haven't done the HDB setup because it requires too much time. When you look at the Apache Hadoop, Hadoop is more like an ecosystem or a number of tools working together. It is not a single tool or technology something. It is a conglomeration of number of tools and technologies put together to achieve a given task. And as part of the course, we'll probably be looking at understanding those tools at a very, very high level view. And unless you work on them regularly, you certainly get confused because there's too much nomenclature, too many bugs that happen. The first part of the ecosystem is called Apache Hive, which is, you can say something like equivalent to your SQL, like whatever you do in SQL, Oracle PLSQL, or MySQL. You're managing a large data, so it gives you SQL-like interface to deal with your data. Like you can write a stored procedure in Oracle, high-level language. Your Apache Pig, which is basically scripting language. So using scripting language, you can write a basic program and access and manipulate the data. And this gives two examples of those Apache Pig as well. Next in the ecosystem is Apache Scoop. This is basically a tool or facility that enables data transfer between RDBMS and SDFS. RDBMS maintains secure data, but here we maintain all data in some kind of XML or based on the corner position. If you want to go back and forth, then Apache Scoop enables data transfer between relational database and Apache Hadoop. Most of the applications work on standard input and standard out. Data would be continuously keep on coming, keep on getting out, and that is what we call a streaming interface. Now, when you write a program using streaming interface, so they'll read data from in, standard in. That means any program that can read data from standard in and write to std out can work in a Hadoop framework. And a stream component enables that interaction using access to the data streaming in and data streaming out. We want to define a workflow, which process should run first, which task to be executed first, and then later on. So the entire workflow is managed by Apache Uji. You look at that, and I'm sure you're already getting confused, and I'm done only even half of it. Then Apache Vir, which is basically a tool to deploy a Hadoop cluster, and normally we use Apache Ambari as a GUI to set up a cluster using GUI, that's Apache Ambari. Most of the data we deal with is not a structured data. which can't be like your text, your email, your weblog, your other things. They're all non-structured data, and that means they really can't be put it in SQL syntax, SQL manner. So you keep the data in NoSQL, and then Apache has a component called HBase, which is part of Hadoop ecosystem, which is NoSQL DB from Apache Fountain. We said Apache primarily meant for a cluster setup, number of nodes running together, number of services, applications, and it should take care of when some nodes could fail, others should continue to work, services should continue to work. Then that monitoring and management to make sure the cluster system is up and running and notifying what has gone down, what has to come up, is done by Apache Zookeeper. So Zookeeper, basically, if you have network resource running multiple places, you want to monitor those, Apache Zookeeper does a wonderful and a good job of it. Then Apache Catalog to talk about schemas and other stuff. And slowly, we'll probably cover most of these tools in the due course of time. May not be all, but it is good if you can lay your hand and understand things that will give you more confidence to work with. You'll be much better off without looking at tools, because if the command, if something has to be done, ask the student looking at point blank and should be able to answer and write those codes. Course need to have exams, internal and external. Internal exam would be your 40 marks, external would be 60 marks. Internal is further broken as per BDA guidelines, 10 for assessments and 30 for internal marks. Assessment, as per my way is concerned, I look at teamwork. So I recommend you to make a team of 2 or 3 people size, limited to 3, because 4, I think it doesn't really work. Make your team, work with it and notify me, and that way would work. All assignments can be uploaded in MS Teams or maybe GitHub. And make sure you don't do any plagiarism. Learning half or less is fine, rather than claiming doing everything but without knowing. That will not be encouraged. So anytime you get plagiarism, you probably get 0, both the person who enabled you to copy and the team that copied. So avoid that part at any cost in time. We'll have 2 internal exams, and as far as new education policy, AICT is also recommending to have open book examinations. So first 2 papers would be open book. Third, maybe open book or closed book we'll discuss. I don't intend to conduct 4th one, but if it is needed due to whatever reason, we may conduct 4th and we'll decide whether the 3rd and 4th would be open book or a closed book. But first 2 certainly would remain open book examination. Those who want to go dig deeper, rather than doing a simple assignment, you can probably think of a mini project that will replace all 3 assignments. But what you want to do, you can approach me sometime next week or end of early next week. I want to do a project, so we'll not do assignment, we'll do a mini project, which will be a lot more bigger than what 3 assignments you would do. And you dispense progress regularly. So that choice is also available for the assignment alternative. But of course, whatever project you want to do has to be explicitly discussed, get an approval, and only then you should be able to take it. Now let's look at the syllabus, the way it exists. So today we are not covering any course, content, anything. Just giving you overview. As a 5-module course, first module is on HDFS, which is Hadoop Distributed File System. Distributed meaning different number of machines have their own disk, local disk. So distributed file means when you look at the files from all these systems and you get some kind of a single view, that becomes HDFS. HDFS is basically took the idea from GFS, Google File System, but recommend all of you to read Google File System. I'll do talk about it in a brief. So there's a paper by Vijay Khemawat, which is about 16 pages long. You can search Google file system, you'll get the reference. Read it, become comfortable, because once you understand Google file system, SGFS understanding would become very easy because it heavily depends or takes the ideas from GFS. We will look at MapReduce program. MapReduce basically means run program on different systems, combine their output, and combining output get a single result or whatever you want to get. So that's the MapReduce framework. We'll look at those, how does that work, and do basic programming using MapReduce framework. That means you should be able to write your own program, and that would be your first assignment, to write your own program, making use of MapReduce. Second module continues on the Hadoop tools. We will look at Yarn, which is basically resource manager. Like when you schedule a Hadoop job, which main resource it has to go to, how many tasks has to be created, how many MapReduce jobs. If some job has terminated, a node has died down, can it be gone to another node? So all that part is part of a Yarn, which is called yet another resource negotiator. There are other tools like Ambari, which is a GUI-based tool to set up Hadoop on a cluster, and then Hadoop admin, Hadoop users, other process, running commands, creating things. Last three modules are from the second book, which is basically data analytics, getting business intelligence using different machine learning models. Some of the concepts you studied in 7th semester in machine learning, so you probably to renew, but I would recommend you that renew and refresh your course on machine learning, and you'll find it much easier for a cakewalk. By design, the course is supposed to run we'll have the classes, and I'll talk about that needs to be done. So whatever we do in theory, I'll try to run course practically, demonstrate commands, and if you have your own Hadoop installation, you should be able to run and work with that. We have studied decision trees, like given the data, build a decision tree. Problem with decision tree, sometimes they give you overfitting. And that means if a new data set doesn't pertain to any current data, it will not even get the answer. The problem with decision trees, it could lead to overfitting. Look at those. You know about the linear regression, you will look at linear regression, you will look at gradient descent, which is partial regression, multiple dimensions. You use ANNs or artificial neural network, clustering analysis, basically K means K nearest neighbors, and then association rule mining. If one rule is X, other is Y, is there a correlation? For example, if you buy bread, are you going to likely buy butter or a milk? And that is what is called association rule mining. We look at those concepts. Last module, primaries for text mining. Let's say given large text, given a textbook, or given your email, can you find some meaningful textual information from that email? We'll also make use of naive-based theorem analysis, which you already studied. The concept of support vector machines, which I don't think you studied. Support vector-based machine basically work in true-false classification. We classify either true or false, nothing in between. And we look at how we can modify that to even apply to given data. And then web mining. Web mining is an interesting area. Everybody tries to do that. Scroll the web, go through the web, find it out, run web scrollers and find, can you find something useful from the web and then make use of it? That is called web mining. The social network analysis, your likes, your dislikes, your comments, your photo upload, your multimedia upload, and so on. So forth. We're supposed to have course outcomes, so we'll look at the 4 course outcomes. CO1, basically understand the concept of Hadoop. Look at Hadoop tools, make use of Apache High, Apache Pig, MapReduce framework, Yarn manager, and so on and so forth. Then look at business intelligence using data warehousing and data mining. That is from module 3, 4, and 5. And you basically look at what technique you want to use, and that will basically study the all this. So last three from the second book and first two are from the first book. Now let's look at how the Hadoop originated. So even though this is not part of your syllabus, this lecture, just trying to give you basic background, what it is. So in the Hadoop book, first two chapters are not part of the course. Your course starts from the third chapter onwards. But I'll try to give you a basic idea how things work, be comfortable with it, and only then we start our actual theory classes on the Hadoop part. The way name Hadoop came from is Hadoop was developed at Yahoo, and the project in charge, Cutting, has a son who was an elephant toy, and he has named the elephant toy as Hadoop, and so the Cutting named the project for Hadoop is more like the Hadoop from the son's name, that is where the name got. Primarily, the way Hadoop is designed, to keep things in mind that we need a distributed computing, number of servers to run the programs, and servers are going to be low commodity servers, and low commodity server means like a desktop in the lab or something. These low commodity servers, some server would fail, and even though servers have failed, your programmed application should be robust enough to work. So take into account that while running things, the components would fail, and it should take care of failures and proceed with computing and still give the result. Both storage can fail, both computing can fail, and things will still continue to work. Other part Hadoop basically is designed for is big use scalability. Scalability means if you have more number of machines in a cluster, you can achieve more computing. So it is not a just think vertical scaling where you to add more hardware in a single machine. More machines you add to the cluster, more compute power, more storage you get, and you get a more scalable solution available to you. Even if something goes down, you can still access and use it. The key concept of Hadoop, which is also underlying theme of the MapReduce, is called rather than moving the data, move the program or move the computing. Let's say, for example, on 4 machines, you have part of a textbook. So you have a chapter 1 on textbook 1, chapter 2 on machine 2, chapter 3 on machine 4, and chapter 4 on machine 4, and so on and so forth. And you want to do combined processing to get something from each chapter, look at some keywords, if it occur, not occur, whatever. Or let's say look at dictionary, you want to find a meaning, or thesauruses, and you want to search. So rather than getting all the data in one place, then doing a search, that means you're moving huge amount of data, which is simply affects my performance. So what the underlying paradigm of MapReduce is, moving computation is much easier than moving data. So take the program to the system where data exists, run the program there, get a summary for each of the machines to run the program, and then combine the summary result, filter it out. That is what is called the reduce process. The map process tells you given program where all bits machine all to the current program we move to, copy to, invoke there, run it, collect data, and reduce framework will tell you how to get these process results from the different cluster nodes, combine them, and that is basically the key. Hadoop is designed to deal with big data, and big data has different connotations. First and foremost is the volume. Means you are looking at very, very high volume. So typically you can define big data as the amount of data which my normal computer system cannot process using traditional means. And that is what basically big data means. So if you have a very small device, laptop, which has only, let's say, 100 GB hard disk, and you want to process much larger data which cannot be processed, that means that itself becomes a big data. Or a IoT sensor, which are dealing with only megabytes, then you can't deal with gigabytes. So how do you make use of large number of sensors, each with a megabyte of storage to process even gigabytes of data? So primarily large volume means refers to data size which traditional systems can't process anymore. Now this could be anything, it could be megabytes, terabytes, gigabytes, but typically given that each one has a laptop or a desktop computer system, volume typically refers to petabytes of data. Petabytes of data basically means 1 terabyte is 1000 gigabytes and 1 petabyte is 1000 terabytes. So you are looking at 1 petabyte is 1 million gigabytes, and that is what typically your large volume. But in theory, it basically means the amount of data that a single system can process on its own. Now you look at second part is variety. Data come from different places. Your social interactions like tweets, your Facebook likes or your YouTube likes or dislikes. You upload, people do comment, your Instagram video upload, and all kind of stuff. The other kind of data, variety data, which is called machines, like every time you access a web server, there's a web log generated, you get those logs, who accessed it, what time, how many bytes were transferred, what is the status code, and so on and so forth. Anytime you browse, you click, you hover over a point, you scroll up and down, you scroll left and right, how many pages you click, what did you did, all this belongs to what is called a web click trail. And that also gives you meaningful input, how one can optimize the applications to get a quicker result. Of course, sensor data, large number of sensors give you large amount of data. Then you have a transaction data that also belongs to different kind of variety. Like you buy things on Amazon, you sell things, you pay transfer, money, you pay bills, your other stuff. Then you have a telecom records, you have that as well. The other attribute of big data is called velocity. That is the rate at which data is being generated. If you are doing WhatsApp chat or sending an email, the rate you are generating would be very low, probably generating 1 kilobyte per minute or so. But the moment you go to video or photograph uploaded interaction, your data immediately becomes megabytes of data per second. So how much data being generated at what speed belongs to what we call is velocity part. Then there's a variability, different kind of data, and in the sense that is your data complete? Let's say I'm trying to monitor in a class, I'm trying to monitor age, height, and weight, and few other parameters for all the students. And then I try to look at the temperature as well, or the blood pressure or other vital parameters. And sometimes somebody skips noting your blood pressure, somebody skips the temperature, like we enter, we take temperature note, but forget to enter. So you might have incomplete data. Sometimes somebody even may note down inconsistent data. For example, writing a temperature at 120 degrees Fahrenheit for a human is practically inconsistent. So you might have an outlier, you look at those, and that way you look at, so big data indicates this kind of variation. Data could be complex if you're getting data from multiple sources. You might have to set up relationships. Like one set gives me height and weight, other set gives me your mark, class attendance, something. How do I correlate? Can I correlate? How do I correlate? What is the basis? And you get a correlation of multiple accesses, not a single access, but multiple dimensions, and that leads to complexity. So given the big data characteristics, let's look at some examples. You all familiar with the media, your video, your audio, your photos, and all that. Web data, like you said, web logs, when you access a web server, you always have a log. You can look at those, your click trails. This is actually very interesting from the user perspective or the customer engagement. How many times you click, how many times you enrolled, on which link you hovered over, where do you spend time, that tells you what user was. All the e-commerce sites are very, very particular about click trails or accessing it. This comes under a category called RUM, real user monitoring. And then the text messages, emails, etc. Written docs, your project report, your assignment, other stuff, programming stuff, those become written docs. If you're trying to do some research, let's say generating simulation, doing to do COVID simulation or genomic simulation, you generate a lot of data, work with it, that becomes scientific data. Those are again examples. If anyone would do stock trading, even a single second, we get thousands and 10,000 transactions. So look at a day, we probably get millions, billions of transactions. So overall, it becomes large amount of data. So hence, that also comes under big data category. As an individual, you probably make 10 or 20 calls per day or receive. But if you look at all the 1 billion people, and each one getting 10 to 20 calls, it becomes a big call record, which basically means calling number, call number, date and time of call, was it a holiday, your charging rate, and so on, so forth. So look at those, together becomes big data when it took data for all the people together. Data from sensors, public government records, your death certificate, your birth certificate, your marriage certificate, your house registration, whatever government gives the data. So all these basically different kind of big data you can classify, and dealing with them is a real challenge. So how does my Hadoop processing typically work? Traditionally, we are aware of basic files. The data is stored in a file, text file or binary file, something, or the structured data we keep in RDBMS, run some SQL query and work with it. In LGFS file system, it is different, data is distributed, and LGFS is optimized for sequential reading. You read the data sequentially, chunks of blocks of data, and then you do reading the data sequentially. If you are doing random reading, indexing, searching for a particular index word, it's going to be very inefficient. But whole block, you want to look at how many times a word occurs, or how many times a given sentence is, something of that kind. Want to process it or count the number of other stuff, how many given photos are there. So you become basically sequential reading, and that is what LGFS is designed for. The files we do basically, Hadoop file systems is simple file approach. You write once, read only, we never modify the data. And because we never modify the data, it is only append only mode. And because it never get modified, so once we return even the replicated mode, it will eventually return and becomes coherent. It basically follows a data lake. That means schema on write. I think my earphone is in charge, so I'll probably skip from this and come to the basic skill mode. Give me a minute. Can you guys hear me?
Yes, sir.
Okay, thank you. So data lake is basically look like a lake where water comes in and then water remains in the lake. You do not change the water. You will do boating, do whatever, water remains as it is, you work with it, but water does not change. Same way once data comes in, you do not change the original data, you process the data, generate the result, send the data, but data does not change, and that is what Hadoop follows called data lake concept. And we'll look at how does that really work when we deal with some examples of MapReduce. It is different from warehousing, data warehousing, you might have studied that we look at, is primarily meaning in warehousing. When we write the data into data warehouse, we write as per some schema. And we don't write invalid data. So pictorially, I can basically depict the difference between data warehousing and data lake. Consider three different sources are feeding the data. One goes to data warehouse and one goes to data lake. When you go to data warehouse, you basically get the data, discard the meaningless data or incomplete data or normalize whatever needs to be done. And based on the data, based on the schema in a particular format, you write. So when you write the data into data warehouse, you're creating the schema at the time, and data is returned, and then you do a query. Whereas in data lake concept, when you receive data from sources, the raw data is written as it is, without any changes. Only when you want to process the data, at that time you define the schema. So in Hadoop case, schema is defined on read time, whereas in data warehouse, schema is defined at the right time, and that's the key difference, meaning if invalid data won't be returned, you already modified the data, this is called ETL, extract, transform, and load. Whereas Hadoop data lake concept, original data is written as it is not changed. When you want to process it, you define the schema, read it accordingly, process it, but original data remains intact. As we said, Hadoop ecosystem consists of many components, and we discussed those already. I'll briefly overview, look at HDFS, which we'll study a little bit more in detail, because whole map Hadoop system will remain on HDFS. The Hadoop distributed file system, how does replication work? That does not mean that each data is returned to every node. If my cluster has 10 nodes, my replication factor is 3. I'll be replicating on 3 nodes. So one block will go to some 3 nodes, other data block go to some other 3 nodes, and so on and so forth. To manage the task and processes running, schedule a job, we'll use a yarn, yet another resource negotiator. MapReduce is the framework which basically enables us to move the computing. That means the program goes to the data node where data resides, run the program there, and then get the results, combine them. That's the reduce framework. To look at that part. Then your Hadoop database, you have a HBase and S catalog. I'm not sure how much we'll study as part of the course, but we'll look at MapReduce query tools. We'll make use of Apache Pig scripting as part of the course. We also look at Apache Hive, which is data warehouse concept. That works. We probably look at other tools as well, such as your basically streaming, your Scoop for importing, exporting data into from Apache Hadoop to SQL or RDBMS, transferring data from HDFS to RDBMS. Then for streaming, we will use, which is Flume. I'm not sure we'll do that serialization part for Avro. I've not seen that, possibly no. But workflow define different processes. If you have 2 MapReduce programs, which has to run in a particular sequence, then we define the workflow, and UG is the component that defines that workflow. We'll look at that, and other kind of component. And of course, some basic administration tool, creating, setting up, running these programs. We'll basically look at Ambar is a tool that provides a GUI-based access to set up your Hadoop cluster. But since you don't have a Hadoop cluster, I would say install separately on the Linux machine and then be comfortable with it. And then Zookeeper to make sure all the services are running. If something goes down, it notifies you. You can restart services in other places to make sure that systems continue to run. So summary, we basically looked at overview. As I said, look at the resource material. Books are available in library. I have a some copy PDF file not authorized, maybe unauthorized, downloaded from web, other places. If you want, ask a class rep, I can give it to them and they can access that. But you have to read from the book. More importantly, you have to run things up yourself. So on a laptop, create a setup. If you already have a Linux installed in dual boot mode, then you can simply install Hadoop add-on like download.fall, or if you only Windows, then set up a virtual box, install Linux, and run through command line, and already given resources to do that. And then we discuss the syllabus, components, look at our theory part of it. And you need to do your work, execute the commands, otherwise you won't remember. And as I want you to set up the system, go through it. Next 2 days, I'm busy with the workshop, so I won't be taking classes. So there will be no class tomorrow, Tuesday and Wednesday. We'll have our next class on Monday. And the way I would work is, I would only take 1 lecture a day.
So even though the 4 lectures, so whichever day, 2 lectures, which I believe is Wednesday. So 1 lecture would be theory and 1 lecture is practice. Those who want to do a practice, figure out commands, be online, run it and see how does it work. And that's the way it works. So install your Hadoop setup, make sure comfortable, do your Linux command, and that's the way things are going to work. So if you have any questions, please feel free to ask. And if no, then you can probably drop out. But make sure that you attend the classes. The new principle is insistent that attendance has to be taken. For need to take attendance, those to be accounted for as specific exam purposes. So don't miss the classes. So this week, since I'm not taking any more classes, next class is on Monday. All these slides and materials is available in MS Teams. In the class materials, you can get it from there. Download it, you can look at it, set up Hadoop installation, do a basic review, so that next class when you run things up, you can basically understand and do things up. So I'm done for today. If anybody has any questions, please feel free to ask. Otherwise, you can drop out. Thank you.